Alright, we're going to finish up slant asymptotes with section 3 pre-calc. And what you'll notice is in order to have a slant asymptote, at least for our class, for our purposes, is we are going to have no horizontal asymptote. And how do you get no horizontal asymptote if you have it bigger on top? Again, that's not really a mathematical thing, but if it's bigger on top, the exponent is bigger on top, there's no horizontal asymptote. So that's what you're seeing in all of these. But what you should see more specifically is that the horizontal, the degree in the numerator, is exactly one more than the degree in the denominator. That's a big deal. So that's exactly what happens on this. Let me highlight it for you. So one more. Now as far as what's the equation of the slant asymptote, we can do a little bit more math to this. But if we were just to examine, I know it's small on your page, but hopefully you can kind of see it. That looks like it's the form y equals 1x plus 4. Y-intercept is 4, it goes up 1 over 1, up 1 over 1. Alright, and I'll show you how to get this here shortly. And same thing with this one. If you look at, looks like the y-intercept is negative 1, but then that slope is up 1 right too. So y equals 1 half x minus 1. And then this one, if I'm reading this correctly, it almost looks like that slope is down 2 right 3. So negative 2/3 x. And it looks like that y-intercept is still minus 1. We can investigate that here shortly. So the premise then is, what if you synthetically divide the numerator by the denominator? Okay, well, remember, synthetic division is good as long as it's a linear binomial. Anyway, so what I would do is put 1 in that box. Again, this is how I do it. You know, previous teachers might do it slightly different. And then 1, 3, 2 is your coefficients. So as I synthetically divide, bring that 1 down, multiply by what's in the box, adding, multiply by what's in the box. Now it is important. We do ignore this remainder, but it's important to pay attention to it, because if that remainder were 0, well then it would be a canceling factor, because that means that the denominator factors the numerator and you could cancel it out. So you just want to double check that the remainder does not equal 0. And what do you notice about the answer, you know, the part ignoring the remainder, and the slant asymptote? They are exactly the same. So y equals 1x plus 4, ignoring the remainder, is the equation of your slant asymptote. That's SA, by the way. That's not that. Sometimes my S's look like 5s. So that's how we're going to find the equation of our slant asymptote. Now, I'm not a big fan of dividing by this because it's not a coefficient of 1 here. So I would actually use long division. So let me do long division on this problem. 2x plus 2. And our term is x squared minus x plus 1. And I hope you're okay with fractions, because what times 2x gives me x squared? Well, 2 times 1 half would give me 1. And then x times x gives me x squared. Now distribute that, you'll get x squared. Half of that is 1. But then you have to subtract that off. So this will cancel. That'll be negative 2x. And bring that 1 down. Well, 2 times negative 1 will give me negative 2x. So then distribute it. It'll be minus 2. So this cancels, and you're left with a remainder of 3. Now we ignore that remainder, But what do you notice about our answer? It matches perfectly to this. And same thing with that third one. Again, I don't like the synthetic, so I'm not doing synthetic on this. I know this author like lives and dies by synthetic. Because the leading coefficient's not 1, I would change it to be 3 to do long division. -2, -7. I think it was +3. I guess it doesn't really matter because that's just going to be your clue that you get a remainder. So 3 times what to give me -2/3? I said that wrong. 3x times what will give me -2x squared, and then I just gave you the answer. That's -2/3 times x. And really what I'm thinking of is I want to cancel out the 3, so put a 3 in the denominator, and so I get 1 times what would give me -2. So that's how my brain works. So then I do get -2x squared, and then again, 6 times -2 is -12 divided by 3 would give me -4x. And then as you subtract, that'll cancel out. That'll give me -3x. Bring that 3 down. Well, 3 times what will give me -3? -1. And you can double check that you did everything correctly, because you should get a remainder that's not 0, and that 9 is not 0. And what we end up with is the equation that matches the slant asymptote. So now we finally have everything to put it all together. And, so your slant asymptote, so the degree in the numerator is exactly 1 more than the degree in the denominator. And then either synthetically divide or long division to get the equation of the slant asymptote, and make sure you ignore the remainder. There we go. Those are my own words. I don't think you'll see another math teacher will explain it that way. So in this problem, we're not going to bother with this slant asymptote on this one. None. Wait, what are we doing? Slant asymptote or not? No, because the degree in the numerator is 2 more than the degree in the denominator. But as we look at the next one, yeah, there's going to be a slant asymptote unless they factor out. That might be a thing that you see. So as I'm looking at that at this moment, because I don't want to mess with factoring that. So let's do synthetic division. Because the leading coefficient's 1, I'm going to do this. 1/2, 5, and -4. If you get a remainder of 0, then it would have factored. So bring that 1/2 down. Half of -4 is -2. Adding that straight down and give me 3. Multiply that would give me -12. And you get -16. So my remainder was not 0. So the equation of my slant asymptote would be 1/2 x plus 3. Hopefully that makes sense. So I'm going to move on. Now the next one, you want to make sure that if you're doing this, that it's in standard form in the numerator. So I'm looking at -2x squared. Let's see, that would be -4x plus 3x. So that would be -x and then plus 6. And I would do long division. I don't know why I didn't give myself enough room. Because that negative definitely puts an impact on things. If you find a different way of doing this, or if you have another teacher tell you a different way, then go for it. Do it that way. Now I'm distributing, adding to get 1x plus 6. So that would be -1 to get x plus 1. And when you subtract each term, you get a remainder that's not 0. So y equals 2x minus 1 will be my slant asymptote. And same thing with this last one. You just want to double check that the degree is exactly 1 more in the numerator. I forgot to mention that on this one, but it is true. And then you can I'm going to do a long division because I don't like that that's not 1. So x squared minus 5x minus 6. So 2x, nope, that's not correct. 2 times 1/2 will give me that. Distribute it, and I get x squared. Half of 4 is 2. And as I subtract, these cancel. I'm left with negative 7x. Bring that negative 6 down. Let's see, 2 times negative 7/2. So then I would get negative 7x and negative 7. Wait, there's no x on that. One of these days I'm going to get this answer right. And it changes color on me for some reason. Let's see, half of 4 is 2 times that would be negative 14. Cancel off each color. 14 minus 6 is 8, so we get a remainder. So my answer should be y equals 1/2 x minus 7/2 for my slant asymptote. Feel free to pause at any point, by the way. Do this on your own. So we have a graph that's pictured here. Is this the same problem I did earlier? Nope. I feel like it was the same though. 3x plus 6, doing that long division. Was it on the previous page? Negative 2x squared minus 7x plus 3. Oh, they changed it on us. That's okay. I'm doing long division, as I mentioned, to figure out the slant asymptote, because the degree is exactly 1 more in the top. So that would be negative 2/3 x in order to cancel them out. Let's see, negative 12 divided by 3 would be negative 4. But you gotta change the sign, so then you can cancel. That would be 2x minus 2. So again, that would be 2/3 to get 2x. Let's see, that would be 12 divided by 6 again to give me 4. But then as I subtract them off, we get a remainder of negative 6. So here's your slant asymptote as you draw it on the graph. I'm going to do a very bad job I'm not very good at drawing down 2/3 over 1, or however this looks like. But it does look like it matches up pretty well. That's your slant asymptote. But it also wants the vertical asymptote. Well, there's a vertical asymptote if you set the denominator equal to 0. So subtract 6 and divide by 3 and you get negative 2. So there's your vertical asymptote. Oops. So you might be asked to do multiple things on a problem. And you should be ready for the homework.